Alright, in this video we're going to be going over comparing and scaling investigation 2.2. So starting off with the warm-up, if I have a ratio of 3 to 2, notice that I can double it to get a ratio of 6 to 4. I can triple it to get a ratio of 9 to 6. I can quadruple it to get a ratio of 12 to 8. And I can quintuple it or times it by 5 to get a ratio of 15 to 10. And notice that these are all based off the same ratio. We're all starting with 3 to 2. And I can just keep multiplying it to get a bigger set of the same ratio. So here, let's go and figure out what the scale factor is. How does 7 turn to 35? How does 4 turn to 20? We can do times 5. 7 times 5 is 35. 4 times 5 is 20. Here, how can 48 shrink down to 8? How can 36 shrink down to 6? We can divide both sides by 6. 48 divided by 6 is 8. And 36 divided by 6 is 6. Another way you can think about it is going the other way. I know that 6 times 6 is 36, and I know that 8 times 6 is 48. So depending on how you look on it, you can either like divide going forward or multiply going backwards. So in this lesson, we're focusing on how can we use rates to find the missing value, and how are rate tables similar to scaling. So in real world examples, usually we compare things every day. And so let's go and read these 4 descriptions and figure out what we're comparing. We need 2 sandwiches for each person at the picnic. Here we're comparing sandwiches to people. How many sandwiches for how many people? Those are the comparisons. Here, $5.50 per hour when I babysit for my neighbor. Again, the 2 comparisons here is going to be dollars to hours. How much money do I make for how much hours I work? The mystery meat in the cafeteria has 355 calories per 6-ounce serving. Here we're comparing calories to serving amounts. How many calories for how many servings? Those are the 2 comparisons. And the curious top rings rate is 8.5 kilometers per hour. And here the comparison is kilometers per hour. We're measuring how many kilometers they run for how many hours they spend. So again, reading these 2 problems and seeing what we're comparing is an important part of comparing ratios. So here's our situation. We have 2 different pizza companies, Howdy's Pizza and Royal Pizza. And here, they give us one version of their price. For example, Howdy sells 15 pizzas that were at $1.95, and Royal sells 10 pizzas for $1.20. And we want to compare which one is the better deal. Which one do we make more money? Or which one can we save more money if we order from these 2 different restaurants? So we know that they give us one ratio, and they allow us to give us the same price. Same price for fewer amount of pizza. So we can scale these ratios up and down, and it will still give us the same approximate price. So let's go ahead and start scaling. Let's see, 120. I could, let's see, to get 5, can I cut this in half? So if I want half the number of pizzas, it would be half the cost. Let's see, from 5 here, how can I figure out the price of 1 pizza? Can't I divide 5 divided by 5, 60 divided by 5? So dividing by 5, notice that 1 piece is going to cost 12. And from here, it's really easy just to double. I can double this to get 2 pizzas, triple it. 12 times 3 is going to be 36. 12 times 4 is going to be 48. So I can keep quadrupling it or keep multiplying it to figure out the other prices. Let's see, how can I get 15? Notice that 10 and 5 make 15. So I'm going to add the cost of 10 and the cost of 5. I'm going to do 120 plus 60. I know that 15 pizzas cost 180. Let's do 20. Yeah, isn't that just 10 doubled? So if I have 10 pizzas, it costs 120. And if I double that, it's going to be 240. Isn't 100 just 10 times 10? So I'm going to take 1200 and times it by 10. Right? And here we're adding 50 more pizzas. Again, half of this would be 600, so 50 more would be 1800. And then if I double this one, double 100, it would be $2,400. Right? Again, that's a lot of pizzas. All right, let's go and see Howdy's. I know that for 15 pizzas, it costs $195. So if I want to figure out the cost of 1, I can divide both sides by 15. So 195 divided by 15 should be 13. From here, I can just keep doubling, times it by 2. 13 times 3 is 39. Times 4 is going to be 52. And let's see, for 5 pieces, times 5 is going to be 65. Right? If I want 10 pieces, can't I double this amount? So I can double 65 to get 130. If I want 20 pieces, I can double it again. So I'm at 260 pizzas. Let's see, 10 times 10, I can add a 0 to this one to get 10. And to get 150, again, half of this is 650, so this would be 1950. And then add another 650, we'll be at 2600. So by either scaling down to get 1 or keep multiplying to scale up, we can either divide or multiply, and that can help us fill out the table. So now that we have this table, how much would it cost for 53 pizzas at Royals? So I know that one pizza costs 12, and I want 53 pizzas. I can take the original cost of 1 and multiply by 53 pizzas. How much would 27 pizza at Howdy's cost? I know Howdy costs $13 for a pizza. And if I want 27, I can multiply this by 27. So 27 pizzas at Howdy's can cost $3.51. So let's go and consider their budget. So let's say they're planning to go to Royal Pizza. How many pizzas can they buy for $400? So I know for 20 pizzas, they can buy 240. And if I double that, 40 pizzas, we're going to go over budget. So it has to be something a little bit less than 40. So let's see. Let's do $12 a pizza times 30 pizzas. No, that's 300. That's 31. Closer. 33. Oh, 33. So notice that the price is almost 400. So I'm going to order 33 pizzas, and that will be just enough money underneath 400. All right, what if I only had $96? How much can I buy from Royal? So again, looking at Royal, I know 5 pizzas cost 60. I know that 3 pieces cost 38. So if I add 5 pizzas and 3 pizzas, 60 plus 90, I can buy exactly 8 pizzas for $96. So, if you know the price of one pizza, how can you figure out the price of additional pizza? I can take the price of one and multiply by how many pizzas I want. So how can I write an equation where P is price, N is pizza, and if I multiply the pizza by how much it costs, I can get the price. So let's write 2 equations. All right, and again, I know for that for one Royal pizza, it's going to cost $12 times it by N pizzas. And for Howdy's, we know one pizza is 13, so for every pizza, 13 times how many pizzas we want. So how does the equation help us solve problems like in part A? We can replace N with the number of pizzas. So just like in the previous problem, if I want to figure out 33 pizzas, if I want to figure out how many for 53 pieces, I can just multiply by 53. And if I want 27 pieces, I can just multiply by 27. So I can take my initial value of 1 and just multiply by how many pizzas I want. See, 12 times 53 becomes 12 times n. 13 times 27 would be 13 times n. And it's just a placeholder for how many pizzas we want. All right. Turns out Howdy's price is only available if you pick it up yourself. If you want delivery, they're going to charge a flat fee of $5. So the price of the pizza is going to be the same, but if I want them to deliver, each of these I'm going to add a $5 fee for delivery. So plus $5 for delivery, plus 5, plus 5, plus 5, plus 5, and plus 5. So what pattern do we notice? With the flat fee, we are just adding plus 5 to the column. In part B, you wrote the equation for the cost of a pizza. How does the information represented by the table show up in the table? All right. How does the information based on the equation show up in the table? So notice that in the table, each term is found by multiplying 13. In the table, we start with 13 and keep multiplying. If I represented the change of plus 5, again, it would be the same equation as before, P equals 13n. But notice that each of these is going to be plus 5, plus 5, plus 5. So no matter how much my pizza costs, I'm going to add $5 for that delivery fee. So that's what the delivery equation is going to look like. All right, so let's go ahead and make a graph of both of these. So let's see, this is going to be for the pickup price, and this is going to be for the delivery price. Notice that we can flip through the tabs to move the different points. So let's do 13 for one pizza. If I want 2 pizzas, I'm going to double it. 3 pizzas, I'm going to triple it. 4 pizzas, I'm going to quadruple it. Alright, 5 pizzas is going to cost 65. And we know that 10 pizzas is going to cost 30. Alright, delivery is pretty simple. It's the same numbers, but again, it's going to be plus 5. So again, I know it's 13 pizzas for a pizza plus 5 more. 2 pizzas cost 26. And then 5 more, that would be 31. Alright, 3 pizzas is going to be 44. 4 pizzas is going to be 57. And 5 pizzas is going to be $70 with delivery. Right, again, I know 10 pizzas cost $130, so delivery would add an extra 5. So now we're at $135. So how are these graphs similar and how are they different? So let's go ahead and draw a line. So here's my delivery line. Here's the line for picking it up yourself. And notice that both of these graphs, they're both linear. Both graphs are linear. The difference is that the blue line, the pickup price, is a little higher. The difference is the delivery price is a little taller. And that makes sense, right? If I'm doing delivery, it's going to charge a little bit more than what it costs just to pick it up yourself. So, for the graph, what coordinates represents the cost of 1 pizza, and what represents the cost of 0 pizzas? So notice that right here, we have 1, 2, 3, 4, 5 pizzas. So I want to find the cost of 1 pizza. I need to figure out what the graph is at when x equals 1. The cost of 1 pizza is the height when x equals 1. And how can I find how much 0 pizzas cost? So, same as before, it would be the height when x equals 0. Right? The height when x equals 0. So, let's go and take a look at the pickup price. If I don't order any pizzas, how much is it going to cost me? Notice that if I don't deliver and I don't order a pizza, for pickup, 0 pizzas cost $0, which kind of makes sense. How about for delivery? Let's say I ask them to deliver an empty box. I don't want any pizzas, but I still want them to come over and deliver. I still need to pay that pizza driver, right? Pizza delivery guy. So even though I didn't order any pizza, if I just have them bring in an empty pizza box, it's still going to cost me $5. 0 pizzas, even though I order 0 pizzas, still cost $5. Okay, so 0 pizzas cost 0 if I don't deliver or if I pick up, and if I ask them to deliver no pizza, still just by driving down, I still have to pay them $5. So how can you use rates to find the missing values? We can divide the ratio to find the cost of 1. And then after we have 1, we can keep multiplying to fill out the table. Right? Multiplying both sides is similar to what we do with scaling, right? Scaling and tables are similar because we are just multiplying and dividing both parts. So again, scaling and solving rate tables involve the same process as just multiplying and dividing both parts. So here, let's go over these practices. Let's see, if I cut this in half, it would be 75 calories. And if I divide by 25, it would be 3 calories. So if I eat 75 grams of trail mix, 75 grams, how many calories am I going to need? I know 50 plus 25 makes my 70 grams of trail mix. So I'm going to add the 150 and 75. So that's how many calories I eat for 75 grams. If I have 1350 calories, how many grams of trail mix did I eat? So 1350 is going to be around here. Let's see, if I combine these two, that would be 1350. So I need 300 plus 150. So I need about 450 grams of trail mix. And finally, let's write an equation. Calories equals how many grams of trail mix? It will be the number of grams times 3 per gram. And that's how many calories I'm going to consume. Right, here we have two people making bowls. We have Miriam and Dwayne. So Miriam can make 3 bowls in 2 hours. So in 2 hours, she makes 3. And for Dwayne can make 6 bowls in 3 hours. So here's hour 3, and Dwayne can make 6. So let's go ahead and fill this out. If I cut it in half, 1.5. I keep adding 1.5 until I make it all the way down. Right, if I cut this into thirds, divided by 3, looks like it takes 2 bowls. Dwayne can make 2 bowls in an hour. If I double that, 4 bowls in an hour. Triple that, 6 bowls in 3 hours. And if I keep following the pattern, we get this. So who makes bowls faster? Turns out Dwayne makes it faster. Miriam can only do 1.5 bowls an hour, but Dwayne can do 2 bowls in that same hour. So, Dwayne's a little bit quicker. How long would it take, typo. How long would it take Miriam to make a set of 12 bowls? So if 6 bowls takes 4 hours, if I double both of these, it would take 8 hours for Miriam. And we know that here, Dwayne can make 6 bowls in 3 hours, so if I double that, it would take 6 hours to make twice as many bowls. And finally here, we're going to simplify these ratios. Here you can compare, right? Half of 2/3 is going to be 1/3. Here we have 3/21, so we divide both sides by 3. We have 1/7. And you can use the visual, but again, if we simplify this, it could be 4/5. This would be 1/10. Divide both sides by 3. Divide both sides by 6. 2 and 3. Divide both sides by 27. Divide both sides in half. And divide both sides by 7. Right, and that's going to be our investigation. If you still have questions, please let me know.